All right, so we've talked about what to consider briefly when writing data science reports. We've talked a little bit now about how to communicate information effectively when speaking out loud. And now I wanted to take a step further. So, when you're thinking about including visualizations, either in a report or in a presentation, what is it that you should consider? The goal here is to discuss the basics of really strong visualizations, knowing that some subset of these are what you should consider for your final report. We're expecting the visualizations you include in your final report to be strong visualizations. Now, that said, I don't expect all of you to become professional designers by the end of this course. So there may be things we discuss in this lecture that you're not able to easily incorporate into your final project. Nevertheless, I do want each and every one of you to consider the visualizations you're including in your report and make them as strong and as effective in their communication as possible. So in this one, we've already talked about the audience and the idea that you're telling a story anytime you're writing a report or giving a presentation out loud. Here, we're going to focus in on the visualizations you include both in written and oral communications. So first, I want to introduce the concept very briefly behind the grammar of graphics, and then a play on words of this very famous grammar of graphics. We're going to discuss the glamour of graphics, how to take a good graphic and make it great. So the grammar of graphics is something that has been around for decades now, and it was started by Wilkinson. There's a famous book called The Grammar of Graphics that lays out the grammar for figures. So the same way you have grammar in sentences, where you have nouns and subjects and verbs and direct objects, you can break down the components of a graph and then build them back up using the terminology in this grammar of graphics. This was written by Leland Wilkinson, and it is a very famous book in statistics and computing. And what the grammar of graphics states is that there are three main parts. Now, there are more, but you need information about the data, the aesthetics, and the geometries. If you've made plots and haven't thought about these, that's because it is totally possible to make lots of figures and plots without considering these. But when you break it down into its components, you can really understand each piece, and that allows you more flexibility when then designing graphics. So the major components of the grammar of graphics are summarized in this blog post. So if you don't feel like reading the entire book, you can take a look at this blog post and link on the slides. And you can see that I talked about data, aesthetics, and geometry in the last slide, but there are other facets and components of the grammar of graphics to really customize figures. The idea here is you start with the data. The data determines what the positions and the values are going to take in your plot and how they are going to be encoded. After you figure out what data you're going to plot, you can then choose the plot type. This is known as the geometry, the shape that you're going to be using. Is it a bar chart? Is it a scatter plot? And then after that, you use the stats, the facets, the coordinate system to really customize beyond that. And you can see that this is a pyramid, so each builds on the previous level. So for example, if we were to take this simple plot, this is not a great plot, but it is a plot nonetheless. On the x-axis, we have something that's DISPL. On the y-axis, something that's HWY. And we can see that the data are what we started with here. The aesthetic maps the data to the geometry. It takes whatever the value is for each data point and puts it on the plot. And then the geometry is the type of plot. Here we've specified that we are going to map the data to a scatter plot. So the data are our two variables. We specify that we're going to put the DISPL on the x-axis, the highway on the y-axis, and then the geometry is a scatter plot. Now, this is a very simple visualization, but you can build on these concepts to make very complex and very involved graphics that are still very effective communicating your points. So an example I really like to use is this one, where the data here are what's going to be plotted. We have month, we have tickets received, and we have tickets processed. And one way you could plot this information is what you see here. So we have month, one of our variables on the x-axis, and then on the y-axis we have some value. And above each bar, we can see one is tickets received and one is ticket volume processed. So we're taking all of these data, we're mapping the data to a geometry and then specifying that the x-axis is going to be month And then the y-axis, we're going to have a grouped bar chart where the bars are tickets received and tickets processed. So we've decided it's going to be a bar plot. So I encourage you to pause the video here and think about whether or not this is the most effective way to plot these data, or whether using the principles we've talked about so far in this quarter and what you've learned as you've made visualizations, whether or not there's something better to do here. So pause the video, think on it. And I usually have students come back and tell me when we're in the classroom what they would do here. And so some of the things students suggest is, well, these out to the 100th here doesn't make sense. You don't need these decimal points. We're missing a y-axis label. The title is not particularly informative. We have ticket trend. There's this weird space here between July and August that we don't know why it is. And the numbers are kind of squished together, so it's hard to see exactly what's going on. And invariably, a student also always says, well, we're looking at a trend over time. These bars don't really tell us much. We have a whole bunch of space under these bars, and the only thing that this is displaying is a 161, right? This isn't giving us information about anything other than the height of this bar. So maybe a bar chart's not the right plot. So you can make a plot, you can map your data to a geometry, and it can be a plot that's not ideal, right? This chart does not convey the information as effectively as this one. So the same exact data are plotted here, but a lot of improvements have been made to the aesthetics of this plot. So the grammar of graphics suggests the way in which you put the information onto a plot, and it's also still up to you to figure out which geometry is best. So here we're looking at a line chart. And you can see that the blue and the gray lines follow one another up until May. There's an annotation on the plot indicating that 2 employees quit in May. So it says we nearly kept up with the incoming volume in the following 2 months, but fell behind with the increase in August and haven't been able to catch up since. So then the lines here are directly labeled received versus processed, getting rid of the need for a legend, right? So down up here, you had to figure out blue, red, and then look down here to figure out what the legend is. Here, you look directly at the lines, you know that gray is received, blue is processed, because the lines are labeled directly. And the numbers here are only on the places of the plot where you really care about the differences. You don't need to have the numbers throughout the entire plot. And what this designer wants the management to take away is what you see at the top. Please approve the hire of 2 full-time employees, subtitled to backfill those who quit in the past year. And you can see ticket volume over time is on the Y, is what's being plotted with number of tickets on the Y-axis and time on the X-axis, right? So this is the same exact information, but a different geometry was used here, and it's much more effective in its communication. Now, there were additional changes that have been made. The colors, the direct labeling, only using the numbers in certain spots, using this line to guide viewers' eyes. All of these are tricks you get to consider in your final projects when you are making your visualizations. If you struggle to figure out what graph is most appropriate, or if you just want to explore the other types of visualizations beyond the basic ones we've talked about here, I encourage you to check out data2viz.com. There's a helpful flowchart where you can consider what information you're trying to plot and then figure out the best approaches for you with examples in there. Now, this resource is more focused to the R programming language, but it is still a helpful resource for those using Python. Okay, so we talked about the grammar of graphics where you have data, you figure out what's going to be on each axis, and then what geometry you're going to use to make that plot. How do you go from a okay plot to a great plot? We saw a little bit of that with the ticket volume processed graph, but let's put some ground rules around this. The ground rules here for visualizations is that first you have to choose the right type of visualization. A bar chart might be simple, but it might not be the most effective. You want an informative title. All of the plots in your final report should have an informative title. And an informative title is one that tells the viewer what they should take away. It doesn't just say what's plotted on the axes. That said, your axes should be labeled, or it should be very clear from a subtitle what information is being plotted on each axis. And you should ensure the text is readable. Just because the defaults put it at one size doesn't mean that it shouldn't be bigger in most cases, or sometimes smaller. And it should be readable on a screen because that for your final project, because that's what we're going to be using for your communication. And it's important to keep in mind that a good graphic does all three of these things. It tells you what the point is. Often this is in the title, in your headline. And whatever your point is, you want to use that to determine how you can emphasize that in your chart. What type do you need? What data should be plotted? What colors should you use for your lines or points? What should you highlight? Do you need to have vertical bars in certain places? And do you need annotations? The proof is in the details in the chart, right? The headline has to match up with what your chart says. They have to agree. But you get to decide how to highlight your point, how to emphasize that with your visualization. And then last is a little bit of explaining. What does the final chart show? Do you need a description or legends or keys or direct annotations and some information about source to fully explain what your visualization is trying to do? So whatever your point is, you should know what that is, and your title should highlight that. And that can help determine how you emphasize that with the elements in your chart. And then you can finalize the explanation with a description. That could be the text that you have alongside of it, what you say in your oral presentation, or with, say, a legend, key, or a source. So this glamour of graphics is a play on words between after the grammar of graphics. And the person here is Hadley Wickham. He is the person who implemented ggplot in the R world. So he implemented the grammar of graphics. Then Will Chase gave a very popular talk at a conference last year called the Glamour of Graphics, where Will Chase, argued that to build on top of the grammar of graphics, you need to consider the glamour. And the reason you do this is because it engages more people. Good visualizations make people pay attention. There's also the aesthetic usability effect, and this suggests that people believe information more if it is aesthetically pleasing, if it looks good. And it's also respect to your audience. You should spend the time making your visualizations good and your explanations clear so that your audience doesn't have to work harder than necessary. You put in the work ahead of time so that the people reading your report or listening to your presentation understand without working too hard. So the three parts here are layout, typography, and color. So when we're talking about layout, we're talking about left aligning titles. So these are some of the ground rules. And these are taken directly from Will Chase's talk. I just made slides on my own. So if you left align titles, what this means is you, on this right-hand side, put your titles all the way to the left. This is through studies, has been demonstrated to where our eyes go first. So this is what we make it easier on viewers. We have left align our titles on the plot. So on these, the left is going to be the less than ideal and the right will be the more ideal. The second is don't make people tilt their head. Often defaults in Python programming packages break this rule, and it's up to you to change a default parameter so that people don't have to tilt their head. For example, if I'm trying to read this chart at the left, I have to tilt my head to the left a little bit to see the labels. To resolve this, you can switch the coordinates, put your what was previously your x-axis on the y, and what was previously your y on the x, and now our heads don't have to tilt to read these labels. Alignment should also create clean lines and symmetry. This is something that takes a lot of work and designers are working on all the time. So this might not be something that you have to consider too much in your final project. But when you are making infographics or trying to explain complex bits of data, like this Eurovision rankings from 538, what they were looking was comparing the old system and the new system for 2 different years. You can see there's different countries and the comparison from one year to the next. This is a slope chart, and we're highlighting with some bolding where your eyes should go. So those that had the biggest changes between the old and the new system. Now, those are the data. What you see is that there is left alignment for most text, knowing that some labels can be right aligned, but that each of these has some symmetry in it. Now, some subtitles can be center aligned. The designer actually made a tiny error here. This label should be center aligned, but you can see that there's center alignment and lines of symmetry. If I were to fold over these lines, you could see that there's symmetry throughout. So this is a very well-designed visualization. It's showing a lot of information and drawing your eyes to the places that it needs to highlight its point. The rule here is borders, don't use them. This border adds nothing to this plot. You can get rid of it and it wastes less ink on the paper. And remove and lighten as much as possible. So minor and major grid lines are often not necessary, so you can use a white background. Now, there are times where you care about these grid lines and you can leave them on, but you don't necessarily need them. So remove and lighten wherever necessary. This brings us back to the point we made earlier in the quarter that less is more. You increase your data to ink ratio, have everything on the visualization serve a purpose. There's a general rule in the design world that legends suck, and this is just because it takes us more time to read them. So over here, there is the same information as on the right, where in this one, you have to look up to the top left to figure out who the purple dot represents and who the green dot represents. Whereas if you just directly label on the plot directly, that is easier on us for visualizing. Now, many visualization packages, including those in Python, include legends by default. So this might be one that's a little harder. So you can work hard to get them directly labeled, but I know that that is something that will come in time. The rule here is white space is like garlic. Take the amount you need and triple it. For example, here's a dashboard on the left where you have no idea where to focus, and one on the right, a lot more blank space. Sizing is used to guide your eyes to what we want to focus on most. So know that white space, when you are presenting information, is not always bad, and there's a balance between all of these. So these are the ground rules. Keep these in mind as you're trying to improve your slides or your figures or your visualizations. With that, I wanted to very briefly talk about iteration. This is an exercise taken from Allison Hill, and she was inspired by PolicyViz. And the idea here is to take a sad plot and make it better. And she gave a really great talk on this. But what I want to highlight here is not the details or to poke fun at Allison's previous work, but to really remind you that you are trying to create the visualizations that are most useful and aesthetically pleasing. You don't want them to be unhelpful, and you certainly don't want them to be ugly. So Allison, without going into too much detail, used to use this to talk about accesses to services. And she looked at this and decided that this falls in the ugly but helpful. So she could explain, and this could be a helpful visualization. But she decided because it was ugly, she was going to try to make it more aesthetically pleasing. And arguably, this one is prettier, but it's not very useful. If you take a quick look, there's a lot of text you have to read to understand what's going on. And there's these pie charts down here that correspond to time, and that somehow corresponds to these lines up here. So Allison decided to improve upon these two, which showed the same information and aimed to be useful and pretty. And this takes time. So it takes iteration. So she started with this plot, changed the colors, removed the background and the grids, then worked to directly label to get rid of the legend, and then started adding in helpful annotations to start guiding viewers to what it is they need to know to understand the graphic, adding lines to guide the viewer to look between time 1 and time 2 at the differences between the blue, adding further text to explain what's going on. Now, all three of these show the same information, but this last one is both aesthetically pleasing and the most useful. So there are things you can do to change and make it even more useful by maybe showing the underlying data. Now, this is a case where you then have to move a legend out to make it work. So there are exceptions to every rule. But maybe you don't even need that color, and you can get rid of all distraction by making it black and white and really make your point. So the goal here is on your final projects, take a sad plot and make it better. Iterate. It takes time, but you want to aim for it to be both useful and aesthetically pleasing so that your viewers don't have to work hard. The last point I want to make in this video is that there are differences between visualizations for listening, for oral presentations, and those for reading. When you're presenting, you want to avoid reading directly off the slide. So you don't need a ton of words on your slides. You want to limit the number of words. And you want to use animation to build your story and to not to distract. So you can use adding lines or adding circles to a plot to highlight different parts as you say the words. And the one thing when you are presenting, you should always introduce your axes. You have looked at this visualization before, and your audience has not. So you have to tell them what's plotted on each axis and then tell them what it is that you're trying to display. You have the benefit of you having words to explain out loud what it is you want readers and viewers to take away. So for example, this is an example I like to use where I would, if I were presenting this out loud, to say my coworkers at Moonville, I would say, okay, so we released Moonville in September 2013. What you're looking at here is time on the x-axis and the number of active users on the y-axis. We had only a few users shortly after we released Moonville, and we saw that we had a steady increase throughout the year, but it wasn't until we had our redesign where in 2014 we saw this big jump in active users. That was steadily growing until the end of 2014. And upon our marketing blitz, we saw a huge spike in in users, and we would expect by June 2015, this number to break 100,000. Right, so I have the benefit of being able to use my words and animations to guide viewers to understand what's going on in this visualization. Reports, on the other hand, are for reading. You can put more on a single visualization because readers get to spend as much time as they want understanding it. And the explanation must be there in text because you don't have the spoken word to benefit. So you have to have it either on the visualization or in the report, and it must be clear. The benefit you have here is that people have time to look at what you've sent them, at the report, at your email, at the visualization, that you don't have when you're going through, say, a slideshow. So that same visualization I just showed might look different if it's in a report than if it's in an oral presentation. So often I have to develop two different sets of visualizations, one for what's going to go in a paper or in a tutorial, and then one is that I'm going to present, where the tutorial has more annotation and information on it, and the one I'm presenting out loud would have less. So this same information is what I would do if I were displaying this in a report or print. Notice that I still highlight we will surpass 100,000 active users in June. The take-home message is clear. I've added these numbers to highlight the places I want people's eyes to go, and I have explanations of what I said previously when I was presenting out loud. But here, this is a good visualization for a report. So have informative titles. Make sure you use the right type of figure. Adhere to less is more. Make sure the mappings are clear. Maybe you need a legend. Maybe you directly label. Your color should be consistent throughout a presentation or throughout a report. The take-home message of each visualization should be clear. Alignment should be considered, and you should use white space if needed. A reminder to everyone that this process takes longer than you would expect. You could spend hours on a single figure, and I have many times in my life. But you worked really hard to understand the data and do your project. Show it off. You get to do this through the presentation of your results, so you should spend the time to do this effectively for your final project. With that, that is the end of how to communicate effectively, both spoken and written and through visualization. And I hope everybody takes this not just for their COGS 108 project, but into their future and as they start making visualizations and writing reports in their future jobs.